Hello, YouTube. So, I recently started getting interested in chainsaws, and that led me to watching a bunch of YouTube videos and seeing that people were modifying chainsaws by porting them. And so, if you don't know what porting a chainsaw or a small two-stroke engine means, is you change where the ports physically are located within the cylinder of the engine in order to make the thing run a little differently. And to do that, you need to be able to measure where the ports are, where they open and close as the engine rotates. So to do that, you need a timing gauge. And there are basically two types. There's one that's a wheel that has a bunch of, every angle, in 1 degree increments marked on it. And you attach that to the crankshaft of the engine, and then you attach a little pointer so you can read where the engine is as you rotate it. The other type is one that I saw Dino Joe making, and he's using a digital angle gauge that he puts inside a little square box with a drill chuck on the back. His box is metal because this angle gauge has a magnet in the bottom, so it can stick to metal like so, this piece of steel. My welder isn't hooked up right now, and I have a 3D printer, so I figured, well, why not 3D print one? So I bought myself an angle gauge off Amazon, 20 bucks. I bought myself a cheap keyless drill chuck, 20 bucks. And I designed up a little adapter so that I can, insert the angle gauge and attach the drill chuck to the adapter, and then you put this on the crankshaft of the engine, and as you rotate the engine, the digital gauge will show you what angle you're at. So this works. There are some issues with it. One, it's $40 a parts, which isn't bad, but obviously you need the gauge. Like, that's kind of the whole point. You don't really need the drill chuck, though, is kind of what I realized after I built it. Of course, this is the way these things always go. You design and print or build something, and then you immediately realize what you did wrong. So I did a couple things wrong. One, don't really need the drill chuck. Also, the drill chuck, some do and some don't, but this particular one has some little serrations on the jaws. So when you're clamping it on the crankshaft on the output side of the engine where the clutch goes, that's actually, on my saws, that's where the clutch bearing rides. So you really don't want to mess up that surface. Maybe you wouldn't. I'm running clone saws. I've heard people say that the crankshafts on those are a little soft compared to the OEM saws. It would be easier just to not, be clamping something with steel serrated jaws on it. The other issue is, if anyone else wanted to build this, you do have to have a lathe to be able to make this work. So the way I did this is the drill chuck that I bought comes with several threaded adapters. So this is a threaded adapter for an SDS hammer drill. So normally it's got a shaft sticking off the back of it. Well, I cut that off in my portaband, and then I drilled a hole through the back and tapped it for this quarter 20 little low cap head screw. And then it's nice, though, because it has a hex on it, so I designed the hex into the 3D printed part, so this is really solidly locked in there. Then the drill chuck screws on, and then for extra insurance, this screw drops through the chuck and screws into there. So the other thing I did wrong, so I put this hole in there, and this hole lets you use an Allen key to push out the angle gauge if you need to do anything with it. Well, you can see I've got 2 holes in here now. I only designed it with 1, and of course the first time I tried to push that out, it just cocked the gauge over to the side and I couldn't get it out. So I pressed through the middle. Did I press through the middle? I can't even remember what I did. Maybe I hadn't put this bolt in yet. I got it out and then I immediately drilled another hole. So that's another issue. Like, you can't really get the gauge out very easily if you need to. I also put this little thing on the bottom. I was going to put a little piece of steel here so the gauge could sort of attach itself to this bracket through the magnet pulling on the steel. Turned out I didn't need to. This is actually a pretty tight fit. Just, you know, the way the tolerances came out on my print versus how I designed it, you know, you definitely don't need that, so I can get rid of that. So anyway, you know, mostly for the drill chuck stuff, I moved on to version 2. So the first thing you'll notice is I cut these corners out. And so the way that works is you put your gauge in there and then you can just grab it and pull it out very easily. So that part's great. One thing I messed up here is on this corner. So I'm printing it like this, where the build plate is here. And so I used support here and here, which you can see that, you know, you can see the support was there, but it came out pretty good because that's a pretty steep angle. And I also had support under this, but I put a radius there. I tend to radius everything. And so it's almost coming to a point there. So it looks a little messy because that's not really a great thing to build on top of a support raft. The other thing I did is I added an extra piece. So let's see. So I added this piece. So this is like a split collar basically, with this little feature on the back that engages with this, with the part that holds the gauge. And the idea here is that you've got a bolt and a washer and a captive nut on the back side, and then you can print up these split bushings to go in here to match the size of your crankshaft. And then you just tighten this up and it flexes and closes down on the crankshaft. So I designed these to be the same nominal size as the crankshaft, and I think it actually came out a little small, but when you push it on there, it flexes open a bit, and then when you tighten the nut, it squeezes down, and it's a pretty good fit. It doesn't really move. You can, if you grab it, you can spin it on the crankshaft, but as long as you don't, it's fine. And I hollowed the sides out basically so it would flex easier. So there's 2 issues with this design though. One, there's a little bit of slop between this this flexible piece and the body that holds the angle gauge. And that's not good, because when you're measuring the angle on the saw, you know, it's going to be horizontal, but you can get a little flex there, and so the angle can change. And so you're going to have uncertainty of a couple degrees on all your measurements. So that obviously defeats the whole purpose of this. So to fix that, we move to design number 3. So it actually uses this piece again, no modifications. This piece works fine. I changed this surface to be flat. It printed much nicer. I added this little boss here with a screw through it. And I don't know if you can see it, but there's a captured nut on the inside there. So what this does when you screw it down, when this is in there, is that screw presses against the side of this and tightens it up. And of course, now I've pressed out my captured nut. This thing's kind of a pain to get in there. But basically the nut is pushing against this, and then the screw is pushing against this. So when you put it together, so you have slop, give it a little tighten, now there is no slop. This is all PLA, so you know, you don't want to really crank down on it. And if you crank down on this and left it on there for a long time, you know, I've read that PLA has issues with creep. You know, you could print it in PETG or, you know, anything else really, and probably wouldn't have these issues. But PLA has been working fine for me so far. The other thing I changed is my split bushing. So I made it longer, and what I'm doing here is it's going through both this flexible part and into the body that holds the gauge. And what that does is it aligns these two pieces, and in conjunction with this screw that's pressing, you know, this piece keeps the flexible coupling part from being able to swing relative to the body. Now it can only rotate, and then this piece locks it in a particular rotation. Another thing that was annoying about this is this bushing could slide around, so I added a little tab at the back that engages with a slot there. So now it's fixed. It can only come out this way when you take the gauge out. So the gauge essentially holds it in. And when you're putting it on, you know, you're pressing it this way. So you're basically pressing this on via the gauge. Although you can also just stick your finger in there. So yeah, this works pretty well now. It also has the advantage of there's less overhang. You know, there's less potential for sag. You know, it sits closer to the body of the saw. So anyway, turned out pretty good. And this is directional. The gauge is slightly larger in one dimension than the other, so you want to put it in the tight orientation. But yeah, this works really well. I'll throw in a picture or maybe some video of it on a saw. I made a bushing for it to work on my MS250 clone. You know, you could just print out another bushing, which takes on my printer a couple minutes, and you're good to go for a different saw size. I only have 2 sizes of saw. I don't think I measured my big one. I've got a G660. I'm guessing that you could make a bushing that would be big enough to work on that as well. And I would just guess that those are kind of the range of what saws might be in terms of crankshaft diameters. But if not, there's plenty of room. You could modify this part and make this hole bigger. The other thing I did here is I cut out this section just so I wouldn't be making the bushing a lot stiffer. you know, in terms of closing up because I extended the length there. That's the reason for that. And I actually tried printing these two different ways. I think this one I printed with this side against the build plate and this one the other way, and I just used tree support, you know, to either come up and support this surface or to come up and support the top. And I think I like it better coming up and supporting this side. I don't know. They both came out totally fine, honestly. I did have to tweak this once on my first go around. This section broke off when I pulled it off the build plate because I made this a little too thin. So yeah, thanks for watching. If anyone's interested in this, let me know and I can find some place to put the files for you.